Alrighty then. Might like to keep that open. Okay. So, info. No, wait, what am I doing? I don't want to. I want to evaluate something. Info. This is just how I open up the info pages for an introduction to programming in Emacs Lisp. Now I think we were somewhere in writing somewhere around here. Interactive options I think is what we were up to. Maybe not. It looks a little bit let's see. Comment follows semicolon. In Lisp, everything on a line that follows a semicolon is a comment. The end of the line is the end of the comment. You can install this version of the multiply by 7 function. In summary, this is how you write code in Emacs Lisp. You write a function, install it, make a function interactive. So let's pick up from here. So first thing I'm going to do is I'm going to get my windows ready. In this window, I'm just going to open up the buffer, the scratch buffer, rather. And here I'm going to open up I think it's in the Dropbox notes. Yeah, I'm going to open up this record of all the sort of questions we have, how we answered them, whether they're still unanswered. Then I'm going to save this to a registry. Just Control X R W. I'm going to save this to I for introduction. And then yeah, we're going to open up something else. So first thing, I'm going to open up an E shell, and then I'm trying to remember the commands for software exorcism.io bin exorcism. Let's load up Firefox. Kind of need it open for this bit anyway. Exorcism.io. Oops. .co.io. Yep. LastPass is still signed in, so that's cool. Because I've still got to open in another window. I'm going to log in. What's my email address? Hopefully LastPass notices the discrepancy, asks me to update. It looks like maybe it won't. Okay. Copy that. There we go. Add. Doesn't realize that it's the same. Sign in, but that's fine. Exorcism download exercise 2 for track eLisp. I think if we just run that, it should go into the right directory. So now it should be pulling the exercise. Yep. Alright, fantastic. Okay, and then we can open it. So home, Nintendo, exorcism, elisp, twofer. And so now we can see what files we have. Whoops. So for some reason we got .exorcism. So we got twofer and then we got twofer test. Let's look at the readme first. So twofer or twofer is short for 2 for 1. 1 for you and 1 for me. 1 for X, 1 for me. When X is a name or you, if the given name is Alice, the result should be 1 for Alice, 1 for me. If no name is given, the result should be 1 for you, 1 for me. Okay. Two-phase short. So I guess it wants me to see what the test says. Oh, I want these around the other way. Oops. No. Window management is definitely not the best in Emacs. What the? Where is it? 2 for test, 2 for. It's just like 2 for .el. Oh, I haven't opened it yet. That's why. Okay. So reopen the README over here. Then open that over there. So 2 for .el code provide 2 for .el into here. Okay. So get that open over there. Test is pretty simple. So maybe just keep I don't know, keep the test over there for now. Okay. And then I'm going to save this in a register, and I'm going to call that E for exorcism. And Control X, RJ will jump to the register, and then I can press I to get back to where I was before. Alright, so let's just quickly go through everything in my little org file of mysteries that we've solved so far. So, what's the difference between a list with an apostrophe in front of it and a list without an apostrophe in front of it? So, the single apostrophe before a list causes that list to return. Without the single apostrophe, the first element of the list will be treated as a command. It's pretty cool. Very easy. So if you have a list, the first symbol in that list will be treated as a command if it's not, if the list isn't prefixed with an apostrophe. Okay, so we had an issue where I was a bit confused about why, if I evaluated here with Control X, Control E, we get 2, but then if I go back, we also get 2. And what we found is, if the cursor is behind a number, like right behind a number, it just evaluates that symbol, the number itself, so not the list, which I guess makes sense, because in a sense it's always doing that. It's just evaluating the list. It's evaluating whatever's in front of it. So if I do that now, we still get a 2, but if I go back to the list, we get a 4. So that was that. Two-faced symbols. So I was a little bit confused about how a symbol could link to both a function and a value. I think, I'm not 100% sure, but I think I figured this out. So when you evaluate a symbol on its own, then it's going to give you the value. It's only going to be evaluated as a function if it's the first atom of a list. So you could have that value, you could evaluate that symbol on its own and it would give you the value stored in it, but if you try and put it at the start of the list, then it'll evaluate as a function. And so what's the perfect way to call the function as opposed to the value? You just use it inside a list that only contains itself. Otherwise, you know, if it was just like this, then it's just gonna try and find the value. So value function list without evaluating the function. So yeah. Then the single apostrophe and listless symbols. So if you put just a single apostrophe in front of a list, you return the list like we just went over. And if you put a single apostrophe before a symbol, it returns the symbol. So again, if we go back here to our scratch buffer and we type symbol and then we try and evaluate that, it's a void variable. There's nothing, there's no value. But if we go here and we evaluate that, we get back symbol, because we're actually getting the symbol, not its value. So it never tries to fetch the value that the symbol points to. So there's no issue there. Markers. So markers are considered similar to numbers, specifically the number of characters for the beginning of the buffer. I don't know why exactly there's a special type for that, why it's not just a number. Maybe that'll become clear later on. Maybe it's some kind of like optimization thing, I'm not sure. P. So functions that contain a P at the end for predicate are used to test whether the argument is a certain type or value. So you could have like is test string P, and then it's like seeing whether the value that the symbol points to is a string or not. So what is the difference between set and set Q? So in set, the first argument is evaluated unless it has a quote before it. That means like the function is run on that symbol. Whatever function is associated with that symbol is run if it doesn't have a single apostrophe in front of it. But with set Q, the argument is automatically quoted, so you just get back the symbol. You don't get it evaluated. Yeah. And so what is the difference between an interactive and a normal function? So I always knew there was something more to it. I was like, is it just that an interactive function has prompts? No, that's not the only difference. The big difference is that an interactive function you can call directly. So I can call it from meta_x. Anything I call from here is an interactive function. I can't call functions that aren't interactive that way. I think maybe I can evaluate them. I'm not sure actually. I'm not sure if I can put them in the eval. Most interactive functions would have some kind of issue if you did that anyway, I think. Unless you fed them in a bunch of arguments, maybe for testing purposes. I think you can evaluate them still. I might be wrong. So buffer names. So when you do like current buffer or something, that's going to return a buffer name, and that has a slightly different format. It doesn't look quite like a string. It has this special format that I got highlighted here. Yeah, so that's the buffer itself being returned. So you're not getting a string, you're not getting a special string. You're actually getting the actual buffer being returned when you call those kinds of things, and you see that kind of prompt in the mode line, in the echo area. Sorry, rather. So other buffer and unexpected behavior. So this is something that's a little bit confusing to watch out for. So there's a function called other buffer. It's for switching buffers. Other buffer chooses the most recent buffer that you cannot see to switch to. So we've got other window for other stuff. So the most recent buffer that you can't see. So if I do other buffer here, interesting. Did I mess it up? Did I write it wrong? Oh, okay, it just returns a buffer, so it's not an interactive function. So you have to go switch to buffer, yeah. Okay, so buffer, so 2 for .el. So if I went, wonder if this is interactive, switch to buffer. Yes, it is. And then I go other buffer. No, that didn't work. Interesting. Let's try switch to buffer, other buffer. No, that didn't work either. Oh, weird. Okay. So I don't quite understand that. Apparently you can't call eLisp in that, but if I did, not that, if I evaluated switch to buffer and then fed it as its argument other buffer, then we get to the other buffer that's non-visible, the last buffer we were active in that isn't visible currently. And then I don't need to like hunt down my buffer, I can just go back Alright. So, an interactive multiply by 7, an overview. So I think we've done all this. Here's the code. Define function, multiply by 7 number, multiply number by 7, interactive p, so you set to p, and for some reason that's really helpful. I think we didn't quite get through all of these. Yeah. So how do I feed a buffer name directly to switch to buffer? Yeah, I'm not sure. Yeah, so I can't feed switch to buffer, just a string of the buffer. Done. What is interactive p? So here we go. P tells the functions to use a prefix argument and pass it to the function. Yeah. Okay, so you can pass an argument to the function based on a prefix argument if you have p as your interactive. Okay. You install this code. Speaking more generally, you invoke a function like this in either of two ways. So by typing a prefix argument that contains the number to be passed, and then typing meta_x and the name of the function, or by typing whatever key or key code the function is bound to. So both the examples just mentioned work ideally to move point forward 3 sentences. Since multiply by 7 is not bound to a key, it could not be used as an example of key binding. A prefix argument, etc., etc. Alright. Let's go over this because I'm not 100% sure I'm 100% switched on about this. So let's go back over this, even though I'm pretty sure we've already gone through it last time. So an interactive multiply by 7. So let's look at the use of the special form interactive and then the function message in the interactive version of multiply by 7. You will recall that the function definition looks like this. Define function multiply by 7, number, multiply number by 7, interactive p, message, the result is %d times 7 number. In this function, the expression interactive p is a list of two elements. The p tells Emacs to pass the prefix argument to the function and use its value for the argument of the function. The argument will be a number. This means that the symbol number will be bound to a number in the line. For example, if you're prefixing argument is 5, the Lisp interpreter will evaluate the line as if it were a message. The result is %d times 75. If you are reading this in GNU Emacs, you can evaluate this expression yourself. First, the interpreter will evaluate the inner list, which is times 75. This returns about a value of 35. Next, it will evaluate the outer list, passing the values of the second and subsequent elements to the list to the function message. As we have seen, message is an Emacs Lisp function, especially designed for sending a one-line message to a user. In summary, the message function prints its first argument in the echo area as is, except for occurrences of %d or %s, and various other sequences which we have not mentioned. When it sees a control sequence, the function looks to the second or subsequent arguments and prints the value of the argument in the location of the string where the control sequence is located. The control sequence being %d or %s or yeah. In the interactive multiply by 7 function, the control string is %d, there you go, which requires a number, and the value returned by evaluating times 75 is the number 35. Consequently, the number 35 is printed in the place of the d, and the message is the result is 35. Note that when you call the function multiply by 7, the message is printed without quotes, but when you call message, the text is printed in double quotes. This is because the value returned by message is what appears in the echo area when you evaluate an expression whose first element is message. But when embedded in a function, message prints the text as a side effect without quotes. Interesting. That's weird. I don't understand why that would be the case, but okay, I kind of get it. Different options for interactive. So in the example, multiply by 7 used p as the argument to interactive. This argument told Emacs to interpret your typing either Control U followed by a number or meta followed by a number as a command to pass that number to the function as its argument. Emacs has more than 20 characters predefined for use with interactive. In almost every case, one of these options will enable you to pass the right information interactively to a function. Consider the function zap2char. Its interactive expression is interactive quote p \nc zap2char :space quote. Okay. The first part of the argument is interactive, is p, with which you are already familiar. This argument tells Emacs to interpret a prefix as a number to be passed to the function. You can specify a prefix either by typing Control U followed by a number or by typing meta followed by a number. The prefix is the number of specified characters. Thus, if your prefix is 3 and the specified character is X, then you will delete all the text up to and including the third next X. If you do not set prefix, then you delete all the text up to and including the specified character, but no more. I feel like we skipped something here. The C tells the function the name of the character to which to delete. More normally, a function with 2 or more arguments can have information passed to each argument by adding parts to the string that follows interactive. When you do this, the information is passed to each argument in the same order it is specified in the interactive list. In the string, each part is separated from the next part by a /n for new line. For example, when you can follow p with a \n and a c zap2char. This causes Emacs to pass the value of the prefix argument, if there is one, and the character. Okay. In this case, the function definition looks like the following, where arg and char are the symbols to which interactive binds the prefix argument and the specified character. Define function, name of function, argument, character, documentation, interactive p, new line, c, zap2char, quote, end quote, body of function. I don't understand how it tells the difference between like the p in zap and the p argument, and then the c in char and the c argument. The space after the colon in the prompt makes it look better when you are prompted. See the definition of copy to buffer, for example. When a function does not take arguments, interactive does not require any. When a function does not take arguments, interactive does not require any. Such a function contains the simple expression interactive. The mark-hole buffer function is like this. Alternatively, if the special letter codes are not right for your application, you can pass your own arguments to interactive as a list. Okay. See the definition of append to buffer for an example. See using interactive eLisp for a more complete explanation about this technique. Okay, we're at a half hour. Starting to feel sleepy because I had some sugar, like a damn fool. I was feeling very energetic until I had that sugar. So I'm going to keep going, but definitely going to go for a walk, burn off that sugar after I'm done with this. What's the time? It's 5 o'clock already. So in about 20 minutes I'm going to pop another energy drink. When you install a function definition by evaluating it, it will stay installed until you quit Emacs. The next time you start a new session of Emacs, the function will not be installed unless you evaluate the function definition again. When you install a function definition by evaluating it, will stay installed until you... Okay. At some point, you may want to have code installed automatically whenever you start a new session of Emacs. There are several ways of doing this. If you have code that is just for yourself, you can put the code for the function definition in your .emacs initialization file. This is deprecated. You should put it in .emacs.d/init.el. Or if you're like me, you put it in an org file and you tangle that with your init file and you run that instead. When you start Emacs, your .emacs file is automatically evaluated and all the function definitions within it are installed. See your .emacs file. Alternatively, you can put the function definitions that you want installed in one or more files of their own. Oh, I should take a quick note. Can feed multiple arguments to an interactive function so long as they are divided by divide special character codes such as P and C with new lines to feed multiple arguments into a function in the order written in the string being fed to interactive. Cool. Alright. So that way I won't forget that. Not just because I can read it later, but also just writing it out just makes me think about it a little bit more. Alright. Alternatively, you can put the function definitions that you want installed in one or more files of their own and use the load function to cause Emacs to evaluate and thereby install each of the functions in the files. See loading files. Thirdly, if you have code that your whole site will use, it is usual to put it in a file called siteinit.el that is loaded when Emacs is built. This makes the code available to everyone who uses your machine. See the install file that is part of the Emacs distribution. Finally, if you have code that everyone who uses Emacs may want, You can post it on a computer network or send a copy to the Free Software Foundation. When you do this, please license the code and its documentation under a license that permits other people to run, copy, study, modify, and redistribute the code, and which protects you from having your work taken from you. If you send a copy of your code to the Free Software Foundation and properly protect yourself and others, it may be included in the next release of Emacs. In large part, this is how Emacs has grown over the past years, by donations. Okay. Whew. I'm going to try and truck on for 10 more minutes before I pop that V. But yeah, I really shouldn't have had that sugar for lunch. Let. The let expression is a special form in Lisp that you will need to use in most function definitions. Okay, so let is used to attach or bind a symbol to a value in such a way that the Lisp interpreter will not confuse the variable with a variable of the same name that is not part of the function. To understand why the let special form is necessary, consider the situation in which you own a home that you generally refer to as the house, as in the sentence, "The house needs painting." If you are visiting a friend and your host refers to the house, he is likely referring to his house, not yours, that is, to a different house. If your friend is referring to his house and you think he is referring to your house, you may be in for some confusion. The same thing could happen in Lisp if a variable that is used inside of one function has the same name as a variable that is used inside of another function, and the two are not intended to refer to the same value. The let special form prevents this kind of confusion. Let prevents confusion. The let special form prevents confusion. Okay. Yeah, we get it. How do I zoom in again? There was a really simple way to do it. Can't remember now. Oh. Let creates a name for a local variable that overshadows any use of the same name outside the let expression. This is like understanding that whenever your host refers to the house, he means his house, not yours. Symbols used in argument lists work the same way. See the defun macro. So this is just talking about scope. So let lets us create a locally scoped variable, essentially. So local variables created by a let expression retain their value only within the let expression itself, and within expressions called within the let expression. The local variables have no effect outside the let expression. So I guess let is like a function that you call and then you run other code inside of let. Well, inside the let list, I guess. Maybe. Another way to think about let is that it is like a set queue that is temporary and local. The values set by let are automatically undone when the let is finished. The setting only affects expressions that are inside the bounds of the let expression. In computer science jargon, we would say the binding of a symbol is visible only in functions called in the let form. In Emacs Lisp, scoping is dynamic, not lexical. I don't quite know what that means. Dynamic versus lexical scoping. Of course, the first thing is a Stack Overflow. Okay, with static lexical scoping, the structure of the program source code determines what variables you are referring to. With dynamic scoping, the runtime state of the program stack determines what variable you are referring to. This is likely a very unfamiliar concept since basically every program language in wide use today, except perhaps Emacs Lisp, uses lexical scoping, which tends to be dramatically easier for both humans and analysis tools to reason about. Consider this much simpler example program written in your pseudocode syntax. Program A, x integer, x equals 1. Procedure B, x equals 2. Which x do you write to? Procedure C, x integer, B. Okay, yeah, okay. I see what they're sort of going towards here. I'll be writing to the first x or the second x. Print x, yep. Okay. The program and compiler refer to both variables as x, but I have labeled them x1 and x2 to ease discussion below. With lexical scoping, we determine at compile time which x we are referring to based on the static lexical structure of the program source code. So, the innermost definition of x in scope when defining b is x1. So what it's saying is when we look at the source code here, this x is inside b, is inside c, which is outside the scope of b, but b exists within a, so this x is not outside the scope of b. So it's saying x1 is in scope, and so the write in question resolves to x1. So even when we call this b from in here, it's not writing to this x, it's writing to this x. Okay? And so the write in question resolves to x1. And that's where x equals 2 writes. So we print 2 upon running this program. So this print x will print that. But that will be updated to 2 by this, because that is within the scope of b at the compile time. With dynamic scoping, we have a stack of variable definitions tracked at runtime, so which x we write to depends on what exactly is in scope and has been defined dynamically at runtime. Beginning to run A pushes x to equal x1 onto the stack. Calling C pushes x to equal x2 onto the stack. And then when we get to B, the top of the stack is x pointing to x2. And so we write into x2. This leaves x1 untouched, and so we print 1 at the end of the program, because we don't get here until we've exited procedure C. So procedure C exits, and then we run that. And then at that point, procedure C's x has been taken off the stack, and we're back to referencing this x. So we end up printing 1 in a dynamic stack. Okay, so furthermore, consider this slightly different program. Program A, x integer, x equals 1. Procedure B, x equals 2. Procedure C, x integer, b, cb. Okay. Note B is called twice. The first time via C, the second time directly. With lexical scoping, the explanation above isn't changed, and we write into x1 both times. However, with dynamic scoping, it depends on how x is bound at runtime. The first time we call b, we write into x2, as explained above, but the second time we write into x1, since that's what's on top of the stack, and he means that's what's on top of the stack when we call this b. Alright? So this x is at the top of the stack when we call this b, but this x is on top of the stack when we call b here. So here is your professor's code, annotated with which exact variable is used on which write. Okay, so then he just goes on with the specific example. So I feel like maybe Python is somewhat dynamically typed. I can't remember. It's been a long time since I've done anything in Python, but yeah, I feel like I remember learning that at some point. Why is that going like that? I might be wrong. Alright. The let special form prevents confusion. Let creates a name for a local variable that overshadows any use of the same name outside the let expression. This is like understanding that whenever your host refers to the house, he means his house, not yours. Local variables created by a let expression retain their value only within the let expression itself and within expressions called within the let expression. So the local variables have no effect outside the let expression. Another way to think about let is that it is like a set queue that is temporary and local. The values set by let are automatically undone when the let is finished. The setting only affects expressions that are inside the bounds of the let expression. In computer science jargon, we would say the binding of a symbol is visible only in functions called in the let form. In Emacs Lisp, scoping is dynamic, not lexical. Let can create more than one variable at once. Also, let gives each variable it creates an initial value, either a value specified by you or nil. In the jargon, this is binding the variable to the value. After let has created and bound the variables, it executes the code in the body of the let and returns the value of the last expression in the body. After let has created and bound the variables, it executes the code in the body of the let and returns the value of the last expression in the body. Okay, so let will return the value of the last expression run within itself, so you won't get any weirdness where it prevents you from getting the return value of something that you would normally be able to get to. Execute is a jargon term that means to evaluate a list. It comes from the use of the word meaning to give practical effect to, Oxford English Dictionary. And since you evaluate an expression to perform an action, execute has evolved as a synonym to evaluate. One moment, guys. Stretch the legs, and now I got my energy drink here to keep me on track. Or just send me veering off the tracks, depending. We'll see what happens. Alright. A let expression is a list of 3 parts. The first part is the symbol let. The second part is a list called a var list, each element of which is either a symbol by itself or a 2-element list. I'm guessing that the first element is a symbol, the second element is the value you want to assign to it. Yeah, the first element of which is a symbol. The third part of the let expression is the body of the let. Yeah, so this is what you want to execute. The body usually consists of 1 or more lists. Okay. A template for a let expression looks like this: let, then var list, then body. So the symbols in the var list are the variables that are given initial values by the let special form. Symbols by themselves are given the initial value of nil, and each symbol that is the first element of a two-element list is bound to the value that is returned when the Lisp interpreter evaluates the second element. Okay. Thus, a var list might look something like this: thread needles 3. In this case, in a let expression, Emacs binds the symbol thread to an initial value of nil and binds the symbol needles to an initial value of 3. Why is needles inside thread? Why is needles inside thread? When you write a let expression, what you do is put the appropriate expressions in the slots of the let expression template. If the var list is composed of two-element lists, as is often the case, the template for the let expression looks like this. So you have a let, then double bracket variable value, then you just close it, then you just have another variable value, close that, then something apparently, boop boop boop, then close that, then the body, boop 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 apparently, and then you close that. Okay. That seems weird. Where's the variable? So this goes around this, and then that goes to there. Why does it seem so odd to me? Oh well, maybe it'll become clearer. So a sample let expression. So yeah, so the following expression creates and gives initial values to the two variables zebra and tiger. The body of the let expression is a list which calls the message function. Message, one kind of animal has %s and another is %s, zebra, tiger. Here the var list is zebra, stripes, tiger, fierce. The two variables are zebra and tiger. Each variable is the first element of a two-element list, and each value is the second element of its two-element list. In the var list, Emacs binds the variable zebra to the value stripes and binds the variable tiger to the value fierce. In this example, both values are strings. The values could just as well have been another list or a symbol. The body of the let follows after the list holding the variables. In this example, the body is a list that uses the message function to print a string in the echo area. You may evaluate the example in the usual fashion. As we've seen before, the message function prints its first argument, except for %s. In this example, the value of the variable zebra is printed at the location of the first %s, and the the value of the variable tiger is printed at the location of the second %s. According to Jared Diamond in Guns, Germs and Steel, zebras become impossibly dangerous as they grow older. But the claim here is that they do not become fierce like a tiger. Okay. This book is full of weird humor, I gotta say. Uninitialized variables in a let statement. If you do not bind the variables in a let statement to specific initial values, they will automatically be bound to an initial value of nil, as in the following expression. I feel like I should probably write something about lets here. The let function. The let function allows you to create locally scoped variables by declaring them in its first argument as a list, and from there the body of the let functions list contains the functions which will use those locally scoped variables. Remember, variables in Emacs Lisp are dynamic. How do I link to a specific info page? Let's look it up. Linking to an info page. Org. Actually, I think I might have done that up here. No, I haven't. Okay. Org mode. Let's see. Org mode buffers, web browsers, chat, other files. External links. Let's try that. File, news, rmail, info. Here we go. Info, org, external links, info node. Okay, so info. So 3.6.3 maybe. See if that works. Sort of. It sort of worked. What's going on? So that goes to the top for some reason. External links. So maybe I can have a space in there? Let's try again. Let's just try copying like the whole title in there. Oh, that's weird. Why is it going like that? Doesn't want What about if I do like boom, 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 oops, boom, boom, boom. Maybe even these guys. No. Let's try info links org mode. Yeah, let's see. Stack Overflow usually has the answer. When in doubt. So I maintain a diary. Currently I do the following. I open the needed info file, press C to copy current node name. Oh, okay. Let C uninitialize let variables. Okay. Let's try pasting that. Hey! Cool! Alright. We got it. So that's cool. C C3.6.3 uninitialized variables in a let statement. Neat. Cool. I did it. Alright. Now we can finally keep reading. So, yeah, if you do not bind the variables in a... Oh, I actually linked to the wrong part of the document. I linked to what I was reading. But actually... Yeah, maybe I'll just link to this overall. So link... Oops. And then C 3.6 let. Oops. Yeah. Yeah, that's fine. Yeah. Right. Looks a little weird, but yep, works fine. Cool. Okay, so uninitializes uninitialized variables in a let statement. If you do not bind the variables in a let statements to specific initial values, they will automatically be bound to an initial value of nil. Yeah, that's fine. So you got one list, and then you got like symbols on their own without a list. Ah, now I get it. Now I get why they were in a list together. Okay. It's not. It's in a list with thread as an uninitialized symbol. Yeah, I was looking at that the wrong way. Here the var list is a list with birch 3 as its atoms, then a pine atom, a fir atom, and then a list with oak and some. If you evaluate this expression in the usual way, the following will appear in your echo area. Here are 3 variables with nil, nil, and some value. Okay. In this example, Emacs binds the symbol birch to the number 3, binds the symbols pine and fir to nil, and binds the symbol oak to the value some. Note that in the first part of the let, the variables pine and fir stand alone as atoms that are not surrounded by parentheses. This is because they are being bound to nil, the empty list, but oak is bound to some and so is a part of the list. Similarly, birch is bound to the number 3 and so is in a list with that number. Since a number evaluates to itself, the number does not need to be quoted. Also, the number is printed in the message using a %d rather than a %s. The 4 variables in a group are put into a list to delimit them from the body of the let. There you go. Mystery solved. The if special form. A third special form, in addition to define function and let, is the conditional if. This form is used to instruct the computer to make decisions. You can write function definitions without using if, but it is used often enough and is important enough to be included here. It is used for oh man, my soy boy hands just like took a beating at the hands of this bottle. Opening this bottle, now I know how my girlfriend feels. Okay, let's start that again. A third special form, in addition to define function and let, is the conditional if. This form is used to instruct the computer to make decisions. You can write function definitions without using if, but it is used often enough and is important enough to be included here. It is used, for example, in the code for the function beginning of buffer. The basic idea behind an if is that if a test is true, then an expression is evaluated. If the test is not true, the expression is not evaluated. For example, you might make a decision such as, if it is warm and sunny, then go to the beach. This is really basic programming stuff, but I'm going to read through it anyway because who knows, Emacs Lisp might treat this totally different. Either way, I need to get the syntax. So an if expression written in Lisp does not use the word then. I haven't seen a programming language that uses then in a while. Maybe batch files on Windows, maybe? The test and the action are the second and third elements of the list, whose first element is if. Nonetheless, the test part of an if expression is often called the if part, and the second argument is often called the then part. Also, when an if expression is written, the true or false test is usually written on the same line as the simple if, but the action to carry out, if the test is true, the then part is written on the second and subsequent lines. This makes the if expression easier to read. If true or false test on one line, then action to carry out if test is true on another. The true or false test will be an expression that is evaluated by the Lisp interpreter. Here is an example that you can evaluate in the usual manner. The test is whether the number 5 is greater than the number 4. Since it is, the message 5 is greater than 4 will be printed. If greater than 5, 4, message 5 is greater than 4. What does if return? I wonder. If 5, 4. Try evaluating that on its own. Don't like that. It needs to have more arguments. Okay. nil. It just returns nil. So if returns whatever the value of its argument is. Kind of weird, so you can't use it to get a boolean. It doesn't return a boolean. That's kind of interesting. It doesn't return anything, it just returns whatever. So the function greater than tests whether its first argument is greater than its second argument and returns true if it is. Of course, in actual use, the test in an if expression will not be fixed for all time as it is by the expression greater than 5 for. Instead, at least one of the variables used in the test will be bound to a value that is not known ahead of time. If the value were known ahead of time, we would not need to run the test. For example, the value may be bound to an argument of a function definition. In the following function definition, the character of the animal is a value that is passed to the function. If the value bound to characteristic is fierce, then the message is it is a tiger will be printed. Otherwise, nil will be returned. So, definition type of animal characteristic. Pardon me. Print message in echo area depending on characteristic. If the characteristic is the string fierce, then warn of a tiger. If equal characteristic fierce, message it is a tiger. If you are reading this inside of GNU Emacs, you can evaluate the function definition in the usual way to install it in Emacs, and then you can evaluate the following two expressions and see the result. Type of animal fierce, type of animal striped. When you evaluate type of animal fierce, you will see the following message printed in the echo area, it is a tiger, and when you evaluate type of animal striped, you will see nil. So it returns nil if the truth condition isn't met. Void. Oh, whoops. Yeah, it does. Returns nil. Doesn't return necessarily what the last argument was. What about 5? And then if I 6, 1, what's that return? 5, I bet. Oh, whoops. Yeah. So if it's true, it returns the value of the last. Otherwise, it returns nil. Interesting. Alright, the type of animal function in detail. Let's look at the type of animal function in detail. The function definition for type of animal was written by filling the slots. Actually, I'm going to make a note of that. What does if return? If returns the value of the value returned by the function, the last function called, provided the if statement is true. Otherwise, it returns nil. That might be does it what about if there is an else? Does if return the value of the last function called by an else if it exists and true is false. I think I know the answer. I assume it's yes, but you never know. I don't know how to write an else statement yet, so. Template for every function that is not interactive is define function, name of function, argument list, documentation, body. The parts of the function that match this template look like this. Blah, blah, blah. The name of the function, type of animal. Okay, I shouldn't rush through this like I am. Type of animal function in detail. Let's look at the type of animal function in detail. The function definition for type of animal was written by filling the slots of two templates, one for a function definition as a whole, and a second for an if expression. The template for every function that is not interactive is define function, name of function, argument list, documentation, body. The parts of the function that match this template look like this. Define function, type of animal, characteristic. Print message in echo area depending on characteristic. If the characteristic is the string fierce, then warn of a tiger. Body, the if expression. The name of function is type of animal. It is passed the value of one argument. The argument list is followed by a multi-line documentation string. The documentation string is included in the example because it is a good habit to write documentation strings for every function definition. The body of the function definition consists of the if expression. The if template for an if expression looks like this. If true or false test, action to carry out if the test returns true. In the type of animal function, the code for the if looks like this. If equal characteristic fierce message it is a tiger. Here the true or false test is the expression equal expression fierce. In Lisp, equal is a function that determines whether its first argument is equal to its second argument. The second argument is the string fierce and the first argument is the value of the symbol characteristic. In other words, the argument passes to this function. In the first exercise of type of animal, the argument fierce is passed to type of animal. Since fierce is equal to fierce, the expression equal characteristic fierce in Lisp, equal is of a blah blah blah. In the first exercise of type of animal, the argument fierce is passed to type of animal. Since fierce is equal to fierce, the expression equal characteristic fierce returns a value of true. When this happens, the if evaluates the second argument or then part of the if, evaluates the second argument or then part of the if message it is a tiger. On the other hand, in the second exercise of type of animal, the argument striped is passed to type of animal. Striped is not equal to fierce, so the then part is not evaluated and nil is returned by the if expression. Here we go. If, then, else expressions. Oh, I'm starting to get a bit bored. How many of these do we have to go? Else, truth and falsehood, save excursion, keeping track of point and buffer, review. Alright. Be doing this over an hour. I'm going to push through. I'm going to push through to an hour and a half. I gotta have some staying power, you know. If then else expressions. An if expression may have an optional third argument called the else part. For the case when the true or false test returns false. When this happens, the second part or then or then part of the overall if expression is not evaluated, but the third or else part is evaluated. You might think of this as the cloudy day alternative for the decision: if it is warm and sunny, then go to the beach, else read a book. The word else is not written in the Lisp code. The else part of an if expression comes after the then part. In the written Lisp, the else part is usually written to start on a line of its own and is indented less than the then part. Okay, interesting. For example, the following if expression prints the message 4 is not greater than 5 when you evaluate it in the usual way. If greater than 4, 5, message 4 falsely greater than 5. Message 4 is not greater than 5, so let's try that out. If greater than 4, 5, message 4 falsely. How do I spell falsely? Falsely greater than 5. Oh yeah, cool. It automatically figures it out. Okay. The indenter can automatically tell that 4 is not greater than 5. It always kind of astonishes me that indenting works so well in a lot of ways without like requiring a huge amount of resources. I guess that's why sometimes it breaks in really counterintuitive ways. Like you think, oh, like obviously that's supposed to be indented and it just doesn't see it because it's like using some kind of shortcut. It's not evaluating all possible options. You know, one thing I like about these headphones is they start to hurt after about an hour, so I can really only do something for like an hour and a half. Cool. So, for example, the following if expression prints and blah 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 blah. Note that the different levels of indentation make it easy to distinguish the then part from the else part. GNU Emacs has several commands that automatically indent if expressions correctly. See, GNU Emacs helps you type lists. We can extend the type of animal function to include an else part by simply incorporating an additional part to the if expression. You can see the consequences of doing this if you evaluate the following version of the type of animal function definition to install it, and then evaluate the 2 subsequent expressions to pass different arguments to the function. Definition, type of animal, characteristic, second version, print message in echo area depending on characteristic. If the characteristic is the string fierce, then warn of a tiger, else say it is not fierce. If equal characteristic fierce, message is tiger, message it is not fierce. Type of animal fierce, type of animal striped. You can see the consequences of doing this. Oh, I see, yeah. Okay, if you evaluate type of animal fierce, you will see the following message printed in the echo area: it is a tiger. But when you evaluate type of animal striped, you will see it is not fierce. Of course, if the characteristic were ferocious, the message "it is not fierce" would be printed, and it would be misleading. When you write code, you need to take into account the possibility that some such argument will be tested by the if, and write your program accordingly. Oh, alright, 10 more minutes. We can do this. We can do this. This is a short one. I reckon we can finish the whole writing define functions. Truth and falsehood in Emacs Lisp. There is an important aspect to the truth test in an if expression. So far, we have spoken of true and false as value. Okay, so I wonder. Get rid of these. So 4, 5. So it returned 5. But then if I switch it around, it will return 4. Yes. Okay. So the if returns the value of whatever the last evaluation was. It returns the value of whatever was last evaluated in the if list. Okay, truth and false. So far we have spoken of true and false as values of predicates as if they were new kinds of Emacs Lisp objects. In fact, false is just our old friend nil. Anything else, anything at all is true. Oh, okay, well then, so if I evaluate this, I get 4. And if I evaluate this, I should get nil. Yeah? Whoa, whoa, whoa. Press the wrong thing. Yeah, 4. Why do I get 4? Oh, whoops. Nil. Okay. And then I can do if that. And then I can have 5, or I can just do 5 and 3, and I predict I will get 3. Yes. Okay. Yeah. Okay. Nil and false are the same thing. Nil and false are the same thing. There is no Boolean type. Only nil versus something. Anything. The expression that tests for truth is interpreted as true if the result of evaluating it is a value that is not nil. In other words, the result of the test is considered true if the value returned is a number such as 47, a string such as hello, or a symbol other than nil such as flowers, or a list so long as it is not empty or even a buffer. Nil has two meanings. Before illustrating a test for truth, we need an explanation of nil. In Emacs Lisp, the symbol nil has two meanings. First, it means the empty list. Second, it means false and is the value returned when a true or false tests false. Nil can be written as an empty list or as nil. As far as the Lisp interpreter is concerned, empty list and nil are the same. Humans, however, tend to use nil for false and an empty list for the empty list. In Emacs Lisp, any value that is not nil, is not the empty list, is considered true. This means that if an evaluation returns something that is not an empty list, an if expression will test true. For example, if a number is put in the slot for the test, it will be evaluated and will return itself, since that is what numbers do when evaluated. In this conditional, the if expression will test true. The expression tests false only when nil, an empty list, is returned by evaluating the expression. You can see this by evaluating the two expressions in the following examples. In the first example, the number 4 is evaluated as the test in the if expression and returns itself. Consequently, the then part of the expression is evaluated and returned. True appears in the echo area. In the second example, the nil indicates false. Consequently, the else part of the expression is evaluated and returned. False appears in the echo area. Incidentally, if some other useful value is not available for a test that returns true, then the Lisp interpreter will return the symbol T for true. Incidentally, if some other useful value is not available for a test that returns true, then the Lisp interpreter will return the symbol T for true. For example, the expression greater than 5/4 returns T when evaluated, as you can see by evaluating it in the usual way. It does too. On the other hand, this function returns nil if the test is false. What happens if I let flowers nil? If flowers, if flowers 5 else 4, bang. Oh, I didn't like that. Setting constant nil. Let flowers nil if, oh wait, hang on. I have to, no. I have to put this inside another list. I think that's where I fucked up. Yeah, so then I get 4. Because flowers equals nil. Flowers. Oops, sorry. Trying to get the value of it. No, that didn't work. Yeah, I didn't think that was going to work either. How do I just return the value again? I can't quite remember. Message. No. Oh, I don't know. Oh, void variable flowers. Okay. Wonderful. All right. Just write that in there. Alright, incidentally, if some other useful value is not available for a test that return, oh yeah, okay. We read that. Okay. The save excursion function is the third and final special form that we will discuss in this chapter. In Emacs Lisp, programs used for editing. The save excursion function is very common. It saves the location of point, executes the body of the function, and then restores point to its previous position if its location was changed. Its primary purpose is to keep the user from being surprised and disturbed by unexpected movement of point. Okay, I'll tell you guys what. I'm getting a little sore sitting here, and this is kind of like not super connected to what we just went over, so I think this is a good point to end it for today, and we'll pick it up tomorrow. So what I'm going to do to make things easier in case we lose our spot is I'm going to create another link. Info IE intro, and then cool. last time. Cool. Oh, whoops. There we go. Make sure it's a heading so it doesn't just end up somewhere hidden away in some other heading. So yeah, that'll be it for today. We won't do any of the exercises today, but let's just refresh our memory of what they were. So, oh yeah, so the two for, so yeah, it'll be a while before we do that, I think. Thanks for joining me today, guys. Later today, I'm going to do some study on Chinese. If you guys are interested in Chinese, definitely check that out. After that, I'm going to get Japanese input set up on my computer again, using something other than the most modern input method. I forget what it's called now. But I had it set up before. It didn't work with Anki, so I'm going to go back to something a bit more old school that I know works. Beyond that, after we've got that Japanese input set up, I'm going to try playing through Pokemon Green version in Japanese, and we're going to work our way through that. So hopefully you guys can join me for that. I'm going to go take a walk now. As important as studying is keeping your brain healthy, and part of keeping your brain healthy is going for regular walks. In fact, it's almost the most important part of keeping your brain healthy. Nothing does better for keeping your brain healthy than that. Not diet, not, doing, brain teasers, doing crosswords or something. No, it's exercising. So I'm going to do that. It'll help me relax. It'll also get the juices flowing wake me up a bit, but it'll also get my brain ready to learn more, build new connections, and it'll also help my attention span, which doesn't hurt either. So I'm going to see you guys in, what's the time now? 6:15. See you guys in about 15-20 minutes, and we'll pick up from there. Have a good one, guys.